Hello there. In this video we're going to prove one of the properties of a parallelogram, that if you start with a shape where the opposite angles are congruent to each other, both sets, this one and this one are congruent, and this one are congruent, then that shape must be a parallelogram. So I'm going to start with our given information, that those opposite angles are congruent to each other, and we'll label them as such. And then I'm going to try to prove that I have these parallel lines. And the way that I'm going to go about doing this is from the previous video, the quadrilateral sum theorem. So all of those angles, kind of ran out of space there, all of those angles add up to 360 degrees. And then I know certain things like A is congruent to C and D is congruent to B, and I can make those substitutions. So I'm sort of color coding here. I replace the C with A and the D with B. And now I can gather like terms for the A's and the B's. And there's 2's in front of both of those, so I can factor that out. And divide. So all of this step here got me to a point where now I know that A and B are supplementary to each other. Now remember, the goal is to show it's a parallelogram, so you can either use that with congruent sides or parallel sides. And I know something about these angles being supplementary, so I can actually say something about the sides. So in purple here, I have these two lines, and then this one cuts through both of them, so this is the transversal, and these are both interior angles on the same side of that transversal, and I know that those interior angles add up to 180 degrees. So AD is parallel to BC by the same side interior angle theorem. Now, to get the other ones, I'm going to do a substitution back in from this step here, that B is congruent to D, and here replacing B with D to get that measure of angle A plus measure of angle D is 180, so that this angle is supplementary with this angle. And that allows me to talk about the lines that are being made with those angles, so this one and this one, where this now, up here, is the transversal. So those angles, A and D, are on the same side of that transversal inside of our candidates. And that gives us that AB is parallel to DC, and enough to make the proof. ABCD is a parallelogram by the definition of a parallelogram. Okay, thanks for watching. Character and Scholarship for Life.